Hello, young neighbors. Welcome to Junior Science. Today we're going to talk about the mysterious power of magnetism.
This is a magnet, and this is a magnet.
Magnets are in places you might not expect.
Now, today we're going to have a lot of fun with magnets, and you can too, right at home.
Some of them are repulsive. Some of them are attractive. Some of them are... Whoa!
Just another way in which science is used to make life better for all of us.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by Bar Magnet. You get 2 poles in every bite.
Magnetism. Magnets. You know, magnets stick to some things, like laboratory doors. Pretty nice decorations, huh? Magnetism is invisible. And magnetism comes from minerals found in the earth. And the earth is so full of these minerals that the earth itself is a giant magnet. That's what makes compasses point north. A compass is just a magnet that's free to move. Now, the most common mineral that can be made into a magnet is iron. Right here is some iron powder, and this is a magnet. Watch. The magnet makes the iron powder form these lines, and we call that a magnetic field. Now, only 3 things can stick to a magnet: iron, nickel, and cobalt. Nothing else will stick. Not rubber dinosaurs, aluminum, silver or copper coins, gold jewelry, but iron sticks great. Now, magnetism comes from moving electrons. You know what we call moving electrons?
No.
Call it electricity. Now, where would we get some electricity? Well, how about from this battery? Now, when I connect this battery, electricity will flow through this coil, and we'll get magnetism. Here we go. Watch. There's enough magnetism to hold up all this weight. Now, what'll happen when we disconnect the wire? Well, the magnetism will stop. You ready?
Sure.
3,
1,000.
2,
1,000.
1.
1,000.
Magnetism is pretty cool.
Jimmy is going to make an electromagnet at home. All he needs is a nail, some thin cloth-covered wire, and a dry cell battery. He wraps the wire carefully around the nail. Now he connects the ends of the wire to the 2 posts of the dry cell. Then he touches the nail to the clips. They hang on in bunches. Jimmy has made an electromagnet.
You live on a magnet. That's right, the Earth is a big magnet. That's what makes a compass work, even way up here. Now, where does the Earth's magnetic field come from? I mean, where are the moving electrons? Well, the Earth is full of melted iron and nickel, and the spin of the Earth makes the electrons flow in huge loops. The Earth's magnetic field extends way out into space. It goes right through the air and water. Spawning fish, migrating birds, and helicopter pilots all use it to find their way anywhere on the Earth. The Earth is a big magnet, and its magnetic field is pretty handy.
I am Martin the Magnificent. Watch as I make these ordinary paper clips disappear. Yes. It's not really magic. It's science.
That's my boy! Magnets are made of metals. Iron, cobalt, or nickel. If a magnet comes near one of these metals, it pulls on it. If a magnet comes near another magnet, it pushes on it or pulls on it. With magnets, likes repel, opposites attract.
Electrons in iron are spinning. Now, on a piece of iron like this, the electrons are spinning all different directions. But in a magnet that's made of iron, the electrons are all lined up, so that a magnet has a front end and a back end, a north pole and a south pole. Now, what would happen if you could cut a magnet in half? Would you get a magnet that was only a north pole or a magnet that was only a south pole? Well, take a look at this. These are the electron cars of science, and they each have a front end and a back end, a north end and a south end. Now, right now, they're parked all which way, but let's line them up like the electrons in a magnet. Back it up, Joe. Okay, Sally. There. Now, let's cut them in half. See, we end up with two smaller magnets. These cars have a north end and a south end, a north pole and a south pole. So if you break a magnet in half, you get two smaller magnets that each have a north pole and a south pole. Near as we can tell, there's no way to get a magnet with just one pole.
Careful. Coming soon to a theater near you, Bill Nye the Science Guy as Compass Man. Follow Bill and his trusty compass as he searches for truth, justice, and magnetic north.
Look, it's Compass Man!
Will he ever find his way?
Not him again.
He'll take you in directions you've only imagined. Compelling, repelling, and attractive. It's Compass Man! In thrilling Magnovision.
Jack is hanging a bar magnet by a string to see if he can learn more about this strange force. Poles that are alike push away from each other. Poles that are not alike pull toward each other.
This train floats over its rails on a magnetic field. It's floating on magnetism, so there's no friction to slow it down. So it goes fast. Really fast! Fast!
Did you ever wonder which way is north? You could tell if you had a compass. They're easy to make. Just rub a needle with a magnet. Always rub in the same direction, like this. Rub it a lot, like 50 or 60 times. Now, put the needle on top of a film cap. It's plastic and it floats. The needle will slowly turn to point north. Science always points you in the right direction.
I'm Ed Weinberger, and I'm a doctor who works with magnetic resonance imaging, or MRI.
It's kind of weird because this big giant magnet can see inside your brain. And the reason why I'm having MRI is because 5 years ago they found out that I had a brain tumor.
And so we'll be able to see pictures of the nose, we'll be able to see pictures of the eye, but more importantly, we're going to be able to see pictures of what's going on inside the brain. Here's the middle of the inside of the brain that we're looking at right now. And so by using this big magnet, we've managed to get pictures, and that helps us look inside the brain. Here are the eyeballs up here. It's sort of cool.
MRIs, they don't hurt at all. They show the doctors what's wrong, if there's something wrong.
So I think we're all done, Vic. Everything looks fine. Thanks.
And today, the news was very good that my brain tumor is not growing back. So I'm very excited.
It's sort of cool.
Now remember, magnets are made of iron, nickel, or cobalt. And the Earth is a giant magnet because its core is mostly iron and nickel. You'll find magnets in all sorts of things that you wouldn't expect. Like doorbells, electric can openers, telephones, stereo speakers, and videotapes, bank cards, refrigerator magnets, and audio cassettes. Very tall metal towers, such as the Eiffel Tower in Paris and the Space Needle in Seattle, are made of steel, which is mostly iron. So a compass needle points right to it. So if you're standing next to it, you could tell. You probably figured it out on your own, though, huh? You know, this is the same compass that Compass Man uses.
Oh, darn it. I'm going to have to throw these out.
Wait, you can keep those weak magnets and have fun, too.
Oh, really? How?
Turning weak magnets into wacky magnets is as easy as 1, 2, 3 with Magnico Wacky Magnet Set. Simply attach your old weak magnets to the backs of the wacky magnet characters, and it's off to the races. Go!
Weak magnets have never been so much fun.
Wacky magnets, new for Magnico.
This is magnetic or not? A screwdriver. Magnetic or not? Cold hard cash. Magnetic or not? A levitating train. Magnetic or not? This has been another Magnetic or Not. Tonight on Opposites Attract, join host Johnny Magnet and find out if last week's winners repelled or attracted.
So, Sam, where are you going for your date? You two are opposites and we're looking for some attraction.
Well, Johnny, I know I like to go see Compass Man. Maybe she does too.
Sure, Compass Man sounds great.
Tune in tonight to Opposites Attract, and we'll see if North meets South.
Hello. Why does this do this? Well, they're magnets, right? And right now, the same side of each magnet is facing each other, so they push apart. We say they repel. Now, you may have heard that opposites attract.
Opposites attract. Opposites attract. Positive, negative, boom. There it is right there, simple. Opposites attract.
Well, it's true. Watch. See that? They pull together. They attract. These magnets are made of iron, and iron is full of electrons, tiny particles that spin around the outside of atoms. Now, when electrons are moving, we call that electricity. So watch. When I close this switch, electricity starts flowing through this wire. And look, the needles of these compasses line up in a circle. Whenever electricity is flowing, a magnetic field forms. So, here are the magnets, but where's the electricity? Well, let's say that this is a microscopic view of iron, and the electrons are spinning around in little areas called domains. Now, normally, the domains are pointing all different directions. The electrons are spinning all which way. But when iron is magnetized, the domains line up. And it's the lined up domains, the lined up little currents of electricity that make iron, nickel, or cobalt a magnet. Our planet, the Earth, is full of iron and nickel, and the Earth is spinning. The iron and nickel is so hot, it's always churning and burning. It's moving, so its electrons are moving. The moving electrons make a magnetic field. The Earth is like a giant magnet, and that magnetism is the same thing that makes compasses point north. The magnetism is looping through our bodies our whole lives. In fact, it's going through you right now. Isn't that wild? Well, thank you for joining me on Consider the Following.
This is Magnetic or Not? An iron butterfly. Magnetic or not? Inagata Davida by Iron Butterfly. Magnetic or not? David Hasselhoff. Magnetic or not? This has been another Magnetic or Not.
The orienteering map we have shows us what is in the park. To help us find our way, we place a compass on the map, and we turn the map to orient the map so that the magnetic north lines on the map are parallel to the needle in the compass. So what we're going to do today is we're going to use the map to find our way around a short orienteering course.
Oh, yeah! Where's that little puncture?
Wherever we are, the needle on the compass is going to point to magnetic north.
Oh, yeah!
So is it that way? Is it that way? Is it back this way? So what? Now, can we also look at the map and we can see that it's near something?
Over here.
Like, is it near maybe a corner of the track?
Oh, yeah! Do we go this way? No. This way? No. Oh, yeah! Tag team.
All right.
Oh, yeah! Tag team. We made it.
The Earth's magnetic field extends way out into space. Charged particles from the sun, called solar wind, hit the Earth's atmosphere, and the Earth's magnetic field makes the air glow. Now, where the Earth's magnetic field is the strongest is at the poles, so that's where the air glows the most. Up here, we call the glowing the northern lights, or aurora borealis. Down here, we call the glowing the southern lights, or aurora australis. Anyway, we end up with these big belts of charged particles held in space by the Earth's magnetic field. They're called the Van Allen belts, named after the United States physicist who discovered them.
Shannon Stapleton, you just won the Magnetic Personality of the Year award. What are you going to do now?
I'm going to go see Compass Man.
Compass Man. Maybe I should go check it out.
The Earth's not the only place with a magnetic field. The sun's got one too. The sun's magnetic field causes sunspots, and they can make your television picture go fuzzy sometimes. I got some more news for you. If you're on Venus, Mars, or the Moon, you won't be needing this compass. You know why? They don't have magnetic fields. Because their cores don't have enough molten liquid metal, and they don't spin fast enough to cause the churning and burning that you need to have a planetary magnetic field. But on Mercury, Jupiter, Saturn, Uranus, and Neptune, there are magnetic fields. On Jupiter, the magnetic field is 20,000 times stronger than the Earth's. On Saturn, it's 10 times stronger. On Uranus and Neptune, it's 100 times stronger. On Mercury, the magnetic field is 100 times weaker than the Earth's. You know what else? The galaxy itself has a magnetic field, but it's millions of times weaker than the Earth's. But it's out here somewhere. You know, this is the same compass that Compass Man uses.
Some animals, like dolphins, birds, and honeybees, use the Earth's magnetic field to find their way home. Humans might need a compass.
At most any toy store, you can find a little horseshoe magnet that will give you lots of fun while you are learning about magnets. Jimmy is moving his things into different piles as he learns whether or not a magnet will pick them up.
This is Magnetic or Not. An aluminum bicycle. Magnetic or not? More cold hard cash. Magnetic or not? The planet Jupiter. Magnetic or not? This has been another Magnetic or Not.
People talk about attraction, it's all all about magnetism. Action picks up a paperclip. Let me give you all a tip. Magnetism even plays a part with microchips to make your computer spin. That's where information begins. Magnets work in a vacuum. I think we can assume they can pull metal things across the room. You talk about magnetic lines. Say opposites attract. That's fine. Opposites attract. Opposites attract. Opposites attract. Opposites attract. Charged particles are moving all around. Movement we can feel doesn't even make a sound. Use the navigation, magnets help us find a way. Our compass points magnetic north at any time of day. Our moon has no magnetic field, but other planets do. The sun has its sunspots, those are magnetic too. From planet Earth right to the sun, or picking up a metal ton. To making a maglev train run, magnets can be a lot of fun. Opposites attract. Opposites attract. Opposites attract. Opposites attract.
Just another way in which science is used to make life better for all of us.
Oh, there you are. Glad you caught up. If you'll excuse me, I've got some serious orienteering to do. See you next week. Should be able to find my way out of here by then. Oh, sorry, Phil.
He knows from the map he carries that if he hikes straight east, he will come to Blue River. By using his compass, he is able to go right to the river, even though he may never have been there before.
Opposites attract. Let's see, it must have been about 1938 when I came up with that idea. Now, you know,
produced in association with the National Science Foundation.
As in myself, as in my idea, nobody else's. But you don't hear about that. They don't talk about that, do they? No, you've never even heard of me. You're looking at me. You have no idea who I am. Me and my opposites attract theory. You've heard of that, haven't you? But you know what happened? I trusted people. I let them into the lab. Back then, back in the 30s, I'm working on it. Opposites attract. I got big signs up, posters. Opposites attract. A world, opposites attract. There it is. I let anybody come in, anybody at all. You know, it was that intern who it was. She comes in, she's looking for my notes, she's copying it down, her own handwriting, not mine. Opposites attract. Opposites attract. But it's not her idea. It's my idea. But what am I? I am nothing. And I'm getting stepped on day in and day out because I keep up with opposites attract. And they're doing it to me. They're doing it. They're doing it.